In this example, we're going to use Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law to determine V sub x, I sub in, I sub s, and the power provided by the dependent source, this dependent source right here. So, first thing we need to do is try to find V sub x. But which one? I see 4 V sub x over here, and I see this V sub x over there. Well, the one that we need to find or determine is this one, because this one is actually a current dependent source depending on this voltage. So this is the one that we're going to look for. So V sub x. Now, in order to determine V sub x, we can try to find this through our Kirchhoff's voltage law loop here, and we're going to go around this loop. So first we can see that we have V sub x, then we have 8 volts over here, and across this 6 amp source we don't have a voltage, but we can see that this is in parallel with these 2 ohm resistors, so that means that this also has a 2 volts across that source. So writing the equation is going to give us the following. We start at minus 2 volts plus the second element plus V sub x plus the third element 8 volts, everything equal to 0, so that V sub x is equal to, this goes on the other side negative and this goes on the other side positive, and it's going to be minus 6 volts. So V sub x is equal to minus 6 volts, and that's the first value. Now let's try to find I sub in. In order to find I sub in, we need to then see that this is a node, this is a node, current I sub in goes into this node, we have this current that comes out of this, and it's going to be this voltage divided by that resistance is going to be 1 amp. 2 divided by 2 is going to be 1 amp. We have 6 amps coming in. Over here we have this other current, and we know this is going to be 8 divided by 2 is going to be 4 amps going out, and then we have this current 4 V sub x going in. Now, what happens with these elements in the middle? Well, if you can see that if I have a current A sub A and I can circle this like a node, I know that if a current goes into an element, should come out of the element the same current. So this current goes in, this current goes out, so I don't need to worry about what's inside because it's going to be the same current. So I can equate this to that, and that's what we're going to do. Kirchhoff's current law 1 will be something like this. I sub in will go into this node, then we have a 1 amp going out, then we have the other current 6 amps going in. Now we have this current over here that is 8 divided by 2, 4 amps going out, and then we have this current in this direction for V sub x. But since we know that V sub x is minus 6 volts, then 4 V sub x is actually 4 times minus 6 is minus 24 amps. And so that means that instead of going in, the actual direction of this current is 24 amps going out. So then we can write current going in, summation of current going in is going to be equal to the summations of the current going out. And so that's going to be current going in is I sub in, the other one goes in is 6, and then equal to the currents going out, that's 1 amp plus 4 amps plus 24 amps, and this is going to be I sub in being equal to 24 plus 4 is 8, 29 minus 6, that's 23 amps, and that's the value for I sub in. Now let's then find this source current, and in order to find this source current, we're going to do the analysis on this node right here, so we don't really have to worry about this side of the circuit. Everything is going to be done on this node, and so we're going to write a Kirchhoff's current law And let's call this node B. At node B, I see that the current comes in, and let's then find this current is going down or out of the node, because passive sign convention says that these currents will come in and will produce a positive voltage. So I know this is 8 divided by 2, 4 amps, like that. We know that this current from the problem before, that this is actually 24 amps going out. And so the only one that we need to determine is this current right here. And so if we apply passive sign convention, we will say, okay, the current flows in this direction because this is the positive. But if we remember, V sub x is actually 6 volts. So the actual polarity here is in this way. So that means that the current must be going in this direction, and this current is equal to 6 volts divided by 4. So let's go ahead and find that current. I'm going to call that current I sub y. So this current I sub y is going to be 6 volts divided by 4, and that's equal to 1.5 amps going in that direction. So let's go ahead and write the Kirchhoff's current law at node B. And that's going to look something like this. Currents going in, well, we have I sub source goes in. Currents going out, well, we have these 1.5 plus 4 plus 24. And so that is 24 plus 4 is 28. That's 29.5 amps, like that. And so that's our result. The next is find the power provided by the dependent source. Okay, again, we have this that is supposed to be 4 V sub x, and the current is in that direction. We know that V sub x is minus 6, so we can then redraw this actually with the current going down, and 24 amps in this way. We know that across this dependent source we have 8 volts with that polarity. So once that we have this, then I can use this as a reference point, and then power is going to be equal to voltage from this terminal to this terminal, that is seen positive 8 volts, times the current. And we know that using passive sign convention says that if this goes into the positive terminal, the current will be positive when I just put it on my equation of power. And so this is going to be equal to 192 watts. And these are, by convention, we know that these are absorbed. Since we are determining the power provided or supply, then we can also say that then this is minus 192 watts supply. And that concludes our problem.